Now, yesterday we completed about the J.J. Thomson atomic model, Thomson model of atom. Now we are going to discuss about the Rutherford scattering experiment. Rutherford alpha scattering experiment. Alpha scattering experiment. Rutherford alpha scattering experiment. Okay, in this, actually, they have done the experiment. They done the experiment by taking up gold foil. Amma. Listen, just this is source of alpha rays. Okay, and this is the source of alpha rays, and they have taken that gold foil. This is very thin gold foil. Very thin gold foil. That will be thin gold foil. Thin gold foil. That is approximately 100 nanometers. 100 nanometers. That much very thin gold foil. Okay. And it produces alpha rays. And he has taken zinc sulfide as a screen. This is zinc sulfide, ZNS screen. To identify the alpha rays. Okay. Okay. When he pass the alpha rays through the gold foil, when he pass the alpha rays through the gold foil, all alpha rays are moving through the gold foil without any deflection. All alpha rays are moving through the gold foil without any deflection. But some are deflected, some angles. Very few, very few are deflected exactly 180 degrees angle. Very few. One out of, this is 1 out of 20,000 rays. 1 out of 20,000 rays, the one alpha ray will come back exactly 180 degrees. Remaining all are moving through the gold foil without any deflection. Very few are deflected some angles. And 1 out of 20,000 alpha rays are exactly come back again. And this, what is the meaning of alpha rays? These are we are calling as alpha rays. Okay. I will give the notes now. Alpha rays is nothing but helium plus 2 amma. Double ionized helium particle. Alpha rays is nothing but H, this is 4, right? So helium plus 2 is called alpha rays, and that means double ionization particle. Double ionization particle. Ionization of helium, it produces alpha particle. Amma ikkada em ledu, helium actually it contains 2 electrons. Our 2 electrons remove it can produce the alpha particles. These alpha particles are passed through into the gold foil, very thin gold foil. All alpha rays are moving through the gold foil without any reflection. The alpha particle. Okay, so this is just assume this is a thin foil and this is ZNS screen. when we pass the alpha rays through this gold file, all are moving through the gold file without any deflection. But very few are deflected some angles. అది ఎందుకు డిఫ్లెక్ట్ అవుతుందో ఇప్పుడు చెప్తా. Very few are deflected some angles and very few, 1 out of 20,000 alpha rays, it will come back exactly 180 degrees. Okay. So from this alpha scattering experiment, actually why he done the alpha scattering experiments means the Rutherford, the J.J. Thomson told about the atom is a spherical shape. Most of the atom it contains completely it's occupied with protons. Yes, and the electrons are embedded in it. The seeds, the electrons are embedded in atom like this. Okay, that means according to his theory, according to J.J. Thomson theory, there is a no space in the atom. So when the alpha particles are strike this atom, all alpha particles should come back. But here what happening? All alpha particles are moving through the gold file without any deflection. That means we can conclude that most of the atom it contains empty space. Most of the atom, I will give the points. He notes రాయిస్తానమ్మా, జస్ట్ వినండి. అకార్డింగ్ టు జేజే థామ్సన్ ఏంటంటే మొత్తం ఇక్కడ ప్రోటాన్ ఉంటుంది కాబట్టి ఎప్పుడైతే ఆల్ఫా పార్టికల్ దీనికి స్ట్రక్ అవుతుందో ఇవి అన్ని బ్యాక్ రావాలా అకార్డింగ్ టు జేజే థామ్సన్ థియరీ. But all alpha particles are moving through the gold file without any deflection. Because of from this we can conclude that total the atom is contained, most of the atom contains empty space. Most of the atom contains empty space. That's why these particles are moving through the gold file without any deflection. And very few are deflecting some angles. For example, if it is the alpha particle ikkada center of the nucleus ikkada side touch ayyindanuko, it can deflect this side some angle, and one more if it strike here, it will deflect some angle. But exactly when the alpha particle exactly struck on the nucleus, it will come back 180 degrees. Okay, so that means according to Rutherford atomic model, the atom is a empty space. Most of the atom is a empty space, and the proton is it contains the proton, it will be in the nucleus mass. Okay, now I will give the points. Just I am removing this one. Every point I will give regarding this Rutherford alpha scattering experiment. Write down very fastly. Did you understand this experiment? Is it any doubts, anyone? No? Is it clear? Okay, right, fine. ఈజీ అమ్మా, ఏం లేదు. ఇక్కడ మనకు జేజే థామ్సన్ ఏంటంటే కంప్లీట్ గా ప్రోటాన్ మొత్తం ఆక్యుపై ఉంటుంది అని చెప్పిండు. కాకపోతే ఇఫ్ ఇట్ ఈస్ ఆక్యుపైడ్ విత్ ద ప్రోటాన్, ఇఫ్ ఇట్ ఆక్యుపైడ్ విత్ మాస్ టోటల్ ఆటమ్, ద ఆల్ ఆల్ఫా పార్టికల్స్ ఆర్ షుడ్ కమ్ బ్యాక్. అవన్నీ కూడా ఇటే వచ్చేసేయాల. బట్ ఆల్ ఆర్ మూవింగ్ త్రూ ద గోల్డ్ ఫైల్ వితౌట్ ఎనీ డిఫ్లెక్షన్. దట్ వీ కెన్ కన్క్లూడ్ దట్ మోస్ట్ ఆఫ్ ది ఆటమ్ ఇట్ కంటైన్స్ ఎంప్టీ స్పేస్. ఓకే, నౌ రైట్ ద Rutherford experiment point. Rutherford observed that in the first one, most of the alpha particles, most of the alpha particles passed through the gold file. Most of the alpha particles passed through the gold file undeflected. A small fraction of alpha particles were alpha particles were deflected by some angles. Deflected by some angles. A very few alpha particles, a very few alpha particles, a very few alpha particles, that is 1 in 20,000, bounced back. That is were deflected by nearly 180 degrees. Nearly 180 degrees. The conclusion above the observation. This is the observation, Amma. Okay. Observation. Observation of Rutherford model. Okay. Now conclusion. The conclusion above the observation. What is that conclusion? Most of the alpha particles went straight. Most of the alpha particles went straight through the metal foil undeflected metal foil undeflected. It means that there must be very large empty space within the atom. Very large empty space within the atom. And next one, since few of alpha particles were deflected from their original path, from their original path, through moderate angles. This is TH. Moderate angles. It was concluded that concluded that all of the positive charges all of the positive charge is all of the positive charges concentrated very small in the atom. Oh, wait. Concentrated and the space occupied by this positive charge is very small in the atom. By this positive charges very small in the atom. Okay. Next, I am removing this one. Next point. So that means very few alpha particles are been, deflected from their original path through the moderate angles. Okay, that means positive part is concentrated very small in the atom. అంటే ఫర్ ఎగ్జాంపుల్ ఇది ఆటం అనుకుంటే ఇక్కడ పాజిటివ్ చార్జ్ ఉంటుంది. ఆల్ ఆర్ మూవింగ్ త్రూ ద గోల్డ్ ఫైల్ వితౌట్ ఎనీ డిఫ్లెక్షన్, దట్ ఈస్ ఫస్ట్ వన్. నెక్స్ట్ ఏంది, కొన్ని మాత్రమే అవుతున్నాయంటే ఇక్కడ స్ట్రక్ అయింది అనుకో, ఇట్ కెన్ డిఫ్లెక్టెడ్ వెరీ స్మాల్ యాంగిల్స్. ఈజ్ ఇట్ క్లియర్ స్టూడెంట్స్? Now I am removing this one. Next, next point, when alpha particles come closer to this positive point, when alpha particles come closer to this point, they suffer a force of repulsion, and deviate from their paths, from their paths. The positively charged heavy mass, heavy mass which occupies only only a small volume, in an atom is called in an atom is called in an atom is called nucleus. Nucleus. It is supposed to be present in the center of the atom. It is supposed to be present in center of the atom. Present in center of the atom. Okay. 1 minute, one more. Next point. There is an empty space around the nucleus. There is an empty space around the nucleus. Around the nucleus called extranuclear part. Called extranuclear part. Okay, extranuclear part. In this part, electrons are present. In this part, electrons are present. And the number of electrons always equal to the number of electrons always equal to the number of electrons always equal to number of protons present in a nucleus. Number of protons present in a nucleus. That is in neutral atom only. Charged atom, the electrons and protons will be different. Next point, the electrons revolve. The electrons revolve around the nucleus. Revolves around the nucleus. Around the nucleus in closed orbits with high speed. In closed orbits with high speed. This model was similar to the solar system. This model was similar to the solar system. Solar system. The nucleus representing that's why this is called planetary model also. Planetary model or solar model. Planetary model or solar model. Okay, copy this one. I am removing next drawbacks. Did you understand this one? Simple. Actually, this is a atom. Okay, the atom, most of the atom, it contains empty space according to Rutherford observation. Why? Because all our alpha particles are moving through the gold pile without any deflection. Okay. So the positive charge heavy masses with occupies with only small portion, small volume of the atom. The positive charge occupies only small volume of the atom. This is called nucleus. This nucleus contains actually at the time of Rutherford they did not discover about the neutrons, but this nucleus contains protons and neutrons. Okay, na? And there is a empty space around the nucleus. This is empty space around the nucleus. This is called nuclear. This is part is in this part the electrons are present. In this the electrons are revolving around the nucleus like planets are revolving around the sun in closed orbits only. When the electrons are revolving around the nucleus like planets are revolving around the sun. That's why this is called planetary model or solar system also. Solar model or planetary model. Okay. Next I am removing this one. The next drawbacks. Drawbacks of Rutherford model. Drawbacks of Rutherford model. Okay. Drawbacks is nothing but simple. Aim ledu. The electrons are revolving around the nucleus in fixed circular path. This is the nucleus and this is the atom. The electrons are revolving around the nucleus. And according to Maxwell theory, the revolving electron it should lose its energy. It will move to near to the nucleus. Finally, it should fall down on the nucleus. If it happens, the atom will collapse. According to Maxwell theory, ఏమవుతుంది రివాల్వింగ్ అయ్యే ఎలక్ట్రాన్ ఎనర్జీ లాస్ కావాలి ఎనర్జీ లాస్ అవుతుంది ఇప్పుడు రివాల్వింగ్ అయ్యే ఎలక్ట్రాన్ ఎనర్జీ లాస్ అయింది అనుకో ఏమవుతుంది అది దగ్గరికి వెళ్ళిపోతుంటుంది సో ఫైనల్లీ ఇట్ షుడ్ ఫాల్ డౌన్ ఆన్ ద న్యూక్లియస్ బట్ దిస్ ఈస్ నాట్ హ్యాపెనింగ్ ఓకే that was explained by the Bose model. Now the drawbacks are this theory could not explain the stability of atom. The first one, this theory could not explain stability of atom. Stability of atom. According to Maxwell, according to Maxwell, this is LL, Maxwell, electron loss its energy continuously. Electron lose its energy continuously in the form of electromagnetic radiation. In the form of electromagnetic radiation. In the form of electromagnetic radiation. As a result of this, the electron should lose energy. The electron should lose energy. The electron should lose energy at every turn. And move closer and closer to the nucleus. and move closer and closer to the nucleus. Closer and closer to the nucleus, following a spiral path. Following a spiral path. So the ultimate result will be will be that it will fall into the nucleus. That it will fall into the nucleus, thereby making the atom unstable. Thereby making the atom unstable. Making the atom unstable. Okay, this is about the Rutherford atomic model. Okay, copy this one. J.J. Thomson model, Rutherford model, both are completed. Rutherford atomic model, he has done the alpha scattering experiment by taking up gold foil. When the alpha rays pass through into the gold foil, all alpha rays are moving through the gold foil without any deflection, right? But very a few alpha rays are reflected some angles, and very few, one out of the 20,000 alpha rays bounced back. Okay, from this experiment he concluded that the most of the atom has empty space. Okay, and the positive charge it's situated at the center, that is called nucleus, and remaining the out of the nucleus, the electrons are present in the out of the nucleus, and the electrons are revolving around the nucleus like planets are revolving around the sun. That's why this is called solar model or planetary model also. Okay, and drawbacks: when the revolving electron, according to Maxwell theory, the revolving electron, its radiation, its energy. Okay, electromagnetic radiation radiates its energy. That means it loses its energy. So that means it moves near to the nucleus. Finally, it should fall down on the nucleus. If it happens, the atom will collapse. But atom is a stable. That means simply we can say he could not explain the stability of atom. Stability of atom. Okay. The remaining class will continue tomorrow. Is it clear, students? I am removing this. I am closing the class now. ఎందుకంటే 1 minute ఉంది కాబట్టి కొత్త కాన్సెప్ట్ ఏం స్టార్ట్ చేయలేం. We can start tomorrow. Did you understand, everyone? Akshay, note the names who are absent today. Tomorrow onwards, I will not allow them to in online class. I will log the meeting starting only. Who are absent today, tomorrow also I will not allow them into the class. Is it clear? Give their names in school. Okay, did you understand this Rutherford atomic model? Everyone? No one are responding. Are you sleeping? Okay, fine.